Welcome back to Science Land with Miss Porter.
And Miss Stilton.
And this lab is meant to be a review. If you have not done this lab, it's an introduction. You're missing out on the discussion with your lab partners, but watching this is better than having no background at all.
Exactly. So our title is Separating a Dry Mixture. So what we are going to do is we're going to take a scoop of salt, a scoop of gravel, and our scoop of powder. But they're all going to be mixed together in one cup.
So when they were on their own, in their own cup, they weren't a mixture yet
Right.
because there were not two or more things, and they were not stirred together. So now we have this lovely dry mixture, and what are we supposed to do, Miss Stilton?
Well, our challenge is to design a method or a procedure to separate this mixture of the three solid materials. The gravel ends up in one cup, the salt will end up in another, and then the powder will end up in the third.
So although we have a mixture, we're going to have to use our knowledge of the properties of gravel, powder, and salt, and our knowledge of the types of ways we can separate them.
Yep.
We did that in past labs.
Exactly.
And come up with the best, clear, step-by-step way to separate this. So gravel's in one cup, salt's in another, and powder's in another.
You got it.
I think the WISE Lab group, before they even start writing anything, would just be discussing.
Yes.
And discussing about what do we know about each of these materials. So one thing I know about gravel is compared to the other two parts of the mixture, it's much bigger.
Yes, exactly, and a lot of irregular shapes too. But you can really see the gravel in this mixture. The salt and powder is a little hard to distinguish.
Yeah, they're both white and
Yeah.
they're both small, but I can see the gravel.
Yes.
And I'm going to make a guess that since the screen worked for the gravel before, I think we should use the metal screen to get the gravel out.
I think that's a great idea.
Good.
We saw it work before, so it should work again.
And since the powder and salt are smaller, I would think they would travel through the screen and
Yeah.
the gravel would get caught.
Yeah.
And with the powder,
Maybe we could use like the filter paper, right? Because that worked before with the powder, catching the powder through it. So, we could, after we maybe get rid of the gravel, we could then do the filter paper cup.
so we get rid of the gravel
Yeah,
first,
yeah,
then we will separate the powder from the salt
definitely.
by using this.
Yes.
I'm a little unsure though, what's throwing me is this is dry. And I don't remember ever working with this dry. The only other time we worked with gravel, powder, and salt, it was not dry. We added water to the gravel, we added water to the powder, we added water to the salt.
That's right. So we never ran the dry mixture through this screen.
Could we try it?
Do you think that would work? Because we did it wet. Maybe if we did it dry, it might catch some of the powder and stuff through too.
So right now, we're still in the planning stage,
Yes.
right? We're developing our plan. I don't know that about gravel, powder, and salt dry. So it might make sense to try it out first to see if it should be part of our plan.
Yeah.
All right, so why don't-
Okay.
Okay.
Let me just tilt this down.
Okay. Interesting.
Huh.
I expected the gravel to stay on top, but I didn't expect the powder and the salt to stay. So I'd have to shove this around. I think this is gonna make a huge mess.
Oh, definitely.
And some of the pieces of salt are
really
so big,
big.
I can see them, and they are not going through the screen. So I'm saying I don't wanna do this dry.
Yeah, I agree with you, because then we still have to separate them, you know, and it's just a big old mess.
Yeah, I don't wanna mess.
Okay. We'll just put
So
that back in there then.
based on our knowledge now that this is just gonna be messy, dry, I wanna add water.
Okay, well, all right, well, that's great, but how much water?
Okay, every time in lab that we've worked together, we've always used 50 ml. So I'm gonna say, let's use at least 50 ml.
50 mLs. Okay, what are we gonna use
What do you mean?
we'll measure 50 mLs?
Well, I just happen to have the syringe right here,
Oh.
because I don't know quite what 50 mLs looks like if I pour it in a cup.
Me either.
So I'm thinking as we write our procedure and we go through steps and it becomes apparent that we need certain tools, maybe we keep like a list in the margin
I think
of
that's
our
a good
tools.
idea, the tools that we'll need. So, well, we're definitely gonna need cups.
Yeah, we're gonna need 3 cups that have labels on them.
Yes.
One with P for powder, one with S for salt,
And
one with G for gravel.
Yes.
Oh, we need another cup
Need
to
another
hold the
cup.
mixture, so
Exactly.
that's 4
So the
cups.
mixture's there,
So we need at least 4 cups.
at least.
And we decided that we're gonna use
Syringe,
a syringe to measure 50 mLs of water.
so we'll need water too.
Yep.
Okay.
And we
Screen.
thought a metal screen. Oh yeah,
Oh, yeah,
stirrer.
Yeah, that's important.
Because-
We're gonna stir up our mixture, right?
Yeah, and I'm gonna suggest, remember powder really needed to be stirred
Yeah.
vigorously in order for it to come up and travel with the water. I think we really need to stir.
Oh, definitely.
And, oh wait,
Ooh, yes, the funnels and the stand, because we decided we wanted to try to use the filter paper to try to separate out the powder.
so at this point, we've done some discussing.
Yeah.
And we've done some listing. If you were in a lab group, you would be writing this down in your own science notebook,
Right.
and you would be really working to make sure that you were clear. So why don't,
Step-by-step instructions are important, just like you've been following in the other labs that we've done. You have the lab steps provided for you. You need to write them down so that if someone came into the lab, they can follow your steps, step by step, and do it.
you know, Ms. Stilfen, I have a lot of students that think I get really picky at this point,
Me too.
and they say to me, well, you know what I meant.
Yep.
And I tell them, well, let's say that Mr. Baker, our principal, or Mr. Roberts, our assistant principal, were to come in and they had to follow your written procedure and they had to meet the challenge of gravel in 1 cup, powder in another, salt in another. They weren't here in the lab when we did our other work. We have to be so precise and
Yes.
clear and accurate in our language that someone from outside the classroom could come in, follow our directions, and get the challenge met.
Exactly.
It's like a recipe.
Exactly, it is. And I also told my students, if they'd ever had this challenge before in previous grades, to try to describe to someone how to tie your shoe or make a peanut butter and jelly sandwich. There are a lot of steps that we just don't even think about. But if someone else had come in and had never done this, never made it before, they have to be really specific, so,
So we're imagining that you have written this down.
yes.
And we're going to do this, we're not going to write something down and show you on the screen. But we're going to do what we imagine someone would have written.
Yes.
So what would you say step 1 would be?
Well, I think the first step is let's add our 50 mLs of water to
Oh.
our mixture.
I'm going to be pickier than that, Ms. Stilfen.
Oh, okay.
Step 1 is to get your tools and materials.
That is true, right, yes.
All right.
And we have our list of tools that we already decided on.
And our getter 1 gets the tools, and our getter 2 gets the chemicals, and our reader reads the steps, and our checker checks them off, and also checks for understanding. If someone doesn't understand why we're doing something, the checker has to make sure that they know why.
Exactly.
Okay, so step 2,
Step 2,
I think we should add 50 mLs of water to our mixture and stir. Do you agree?
I agree.
Okay.
she's adding the water and I'm just gonna stir up our mixture.
Because we really want to get that powder.
Yes.
And I'm going to say that we should have an extra cup,
Oh, yeah.
because I'm predicting that there's only going to be gravel on the screen, and we'll dump it right in the gravel cup.
Good idea. Now, for those of you at home, our mixture here is milky white. I can't see the bottom at all. I can still kind of hear
I can
and
hear the
feel
gravel.
Yeah. I don't know about the salt because it's too milky. I can't see a thing in there.
And remember, salt dissolves,
Mm-hmm.
so we wouldn't be able to see it even if it was clear.
Exactly.
You're being very patient, Miss Stilton.
Yes. And make sure it's dissolved.
Oh, it's dissolved.
All right. You ready?
Yep.
All right. So now we're going to pour our mixture through the screen filter. And if our prediction's correct, it should touch the gravel and allow everything else through it. And of course, all
Hey.
my gravel stuck to the bottom of the cup. But I don't see any powder there or any salt crystals. Any water?
You know, if I were gonna do this again,
Yeah.
I would put a step in there where maybe I rinse
Oh.
the gravel off.
That's a good idea, because you might still have some stuff on the gravel there.
So we didn't write it down, but we haven't written any of these steps
No.
down because we're pretending that we.
Oh yeah, much cleaner.
So if I were gonna write this again, I would add this step that I get to rinse off the gravel with the
50 mL.
syringe and 50 mLs of water. So now,
And gravel in 1 cup. Okay.
ta-da, we're 1/3 of the way through our challenge.
That's right.
We have gravel in a cup. Success.
So I'll label this one our mixture now.
Is it still a mixture, Miss Stilton?
It still is.
Why?
Well, we have water, we have powder, and well, the salt should still be in there, so.
We have 2 or more
2 or
things
more
stirred
things.
together.
You got
So
it.
technically, it's still a mixture. So our next step,
We're going to use the funnel and filter paper.
and what are we thinking that the paper filter will separate out for us?
Well, I'm thinking that just like before when we did it, it separated out the powder, but the salt and water were able to travel through.
Because the salt has dissolved and it's in much smaller pieces,
Exactly.
and it'll fit through those tiny holes
Got it.
in the paper filter. But the powder, even though it's very, very, very small, the powder is still too big to fit through those holes in the paper filter.
Got it.
So I sprinkled to make it easier for this to travel through. You're
I'm gonna
stirring,
stir it up because the powder likes, as we found out, likes to settle down to the bottom.
so we used our knowledge of that property
Exactly.
to make sure we vigorously stirred.
Mhm.
I like that word, vigorously.
Vigor. Yes, that's a
Yeah.
good word.
Vim and vigor. All right, pouring, pouring. Whoa, the water coming
There
out
you
is
go.
much clearer.
Yeah, then when it went in.
And I'm seeing pieces of powder on the sides of the paper filter.
Look at that.
Success.
Ta-da! We're brilliant.
I know.
Slowing down a little bit. It must be because I think the powder kind of clogs up
The
the
holes.
holes. Yeah,
Yeah, it's not as fast as when we just had salt and water.
definitely not.
That was a good observation. Still making its way through.
Still dripping in.
And going, and going, and still dripping. Yeah, it must have really
Wonderful.
clogged
Yeah.
down the bottom.
Yeah.
So,
Oh, look at that powder sitting in there.
technically, I should be able to put that in
Into a cup.
the cup because my challenge says
Has to go into a cup. You can see
The
that
powder
on TV
in-
land.
a pea cup.
All right, so there's the pea cup. Should I just
No.
set it in there?
Yeah, they didn't say we couldn't
Yeah, scrape it
have
off?
a paper filter in
Good.
there. They said
Awesome.
just the powder and not the gravel and the salt.
All right, well,
2/3 away, hooray!
Okay, now we have salt and water.
Well, we have at least twice in lab talked about the process we're gonna use to separate the salt and the water.
Which is a solution.
It is a solution because it's clear. Before it was a mixture, just a mixture. And now we've taken out the parts that won't dissolve, the powder and the gravel. And so all we have left is what will dissolve. And now we have a special kind of mixture called a solution.
Exactly. And not just the answer to a math
Oh, good one. That's a nice science joke. So, do we still have that evaporation dish
do.
from our last experiment? Because we just want to remind you
Exactly.
about
Our evaporation dish.
nobody put a time limit on this. Nobody
No.
said that by the end of a class period you had to have the salt
All
separated
separated.
from the water.
Exactly.
So I'm going to use my science knowledge and the power of evaporation to, over time, say that the liquid in here is going to turn into a gas, become part of the air that surrounds us.
Yes.
And the salt is too heavy, can't travel with the water, which became a gas, which is very light and tends to float up. The solute, the solid part of the solution, is the salt. And so I'm going to say that after a few days' time, we're going to have salt in crystal form in the bottom of the evaporation dish.
Exactly.
And then, after a few days' time, we will have met our challenge.
We're good.
Nice.